Today, we have a very special episode of Dynamically Speaking, where we'll be speaking with Jacob Ideskog to talk about Curity, API security, neo-security architecture, an event that we are co-hosting with Curity on March 26th. So grab your favorite beverage, sit down, and join us. Hi, everyone, and welcome to another episode of the Dynamically Speaking podcast. I'm Emme Reichert, the marketing manager at Axiomatics, and today we have a special episode planned for you as we have a guest. But with me, as always, I have my co-host and our CTO, David Brossard. Hi, David. How are you doing?
Hey there, Emme. Doing great and super excited about this episode and our special guest.
And getting right into that, joining us today is our special guest, Jacob Ideskog, who is an identity specialist and the CTO at Curity. Most of his time is spent working with security solutions in the API and web space. He has worked with both designing and implementing OAuth and OpenID Connect solutions for large enterprise deployments, as well as small startups. Hi, Jacob. How are you doing?
Hi, Emme. Nice to be here. I'm great.
Awesome.
Thanks for staying up late, Jacob. I know it's 10 p.m. for you in Sweden, so thank you.
Yeah, kids are asleep, so no better time for a podcast.
Exactly. Asleep for now.
Asleep for now, for sure.
Can you tell us a couple of words about yourself and how you got to be in the identity world?
Yeah, for sure. I mean, I actually started off with quite a different trajectory. I was working with embedded software. And then I kind of slipped into networks and software-defined networking, and which, a lot of protocols in there. You need to know the protocols pretty well, and there's tons. And after a while, a colleague or a to-be colleague of mine pulled me in and said, we should do something in the identity space. He had been working with banks and doing their identity systems for quite a while, Travis Spencer. And I thought, that sounds interesting. More protocols, higher in the stack, user space programming, that type of thing. So that kicked us off, and that was way back. And I never looked back. I love identity. I think it's awesome.
And that's kind of how Curity was born, right?
Yeah, so we actually started off doing systems integrations, and that's, I think, when I met you the first time. We were solving identity problems, or actually we were solving API security problems. Back then, this was probably 2011, 12. Companies were transforming. They were becoming platforms because they realized, there's this new iPhone that just launched an app store around that time, and people are building apps, and those need APIs. And we have all this data and all these services. We need to start rethinking how we do this, and that required some new tech, or old tech in a new way, I should say. Most of it existed. So what we did was we put that together. We created architectures around that and helped them sort of build this platform. And didn't take too long to realize, well, it's the same architecture all the time, and it's really hard to solve, like super hard to actually implement this with the products that were out there, especially when it came to OAuth and the identity piece, which led us to say, hey, let's not consult anymore. Let's build a product that actually solves this the way we want it to be solved. So yeah, that was the journey. And an interesting anecdote from that period was that kind of led me into, this is a mission. We need to do this. I met with a fairly large media company in Sweden back then. And we were discussing this whole, you should think about APIs this way. And they were doing APIs, and they were a publishing company of some sort. And turns out that everything behind their firewall, everything inside their network was just open. There was no TLS, there was no API security whatsoever, and
implicit trust in a way.
Implicit trust. So whatever they, if someone just pushed something to their API, they could publish it on their platform. and it was like that. Someone's legally responsible for what you guys publish. This could be a big problem. There's a lot of trust to a lot of employees in a pretty big company who didn't see the sort of value of what their APIs could do or the risk in misusing that. And that kind of, made a strong impression on me that this is not how the world should work. Everybody isn't that friendly. We need to be sure we help companies like this out in a better way.
Trust but verify. So you're
but verify.
You're a zero trust guy. Then you very much believe in zero trust and what it promises to do.
I do for sure. I tend to not necessarily talk about it as zero trust. I kind of like to talk about the token-based architecture, but it is zero trust. I think if you talk to the sort of zealots in the space, they might not agree with my definition of zero trust. But yeah, I mean, that's how it should work.
And so just for the benefit of our, I was going to say viewers, but listeners, I suppose, just to frame Curity and Axiomatics, is it fair to say that Curity is more on the authentication side and the basic authorization side and the API protection, and then Axiomatics is the layer on top that provides the fine-grained authorization? Jacob, do you think it's a fair representation of how we work together?
Yeah, I would say so. I mean, I've always considered Axiomatics and Curity to provide two very complementary products and work in two very adjacent spaces. Kind of the same. If you talk about API security, we're in the same space. We're just solving two different things, two pieces you need in there. We do the not just the authentication, but the whole like identity transport. Like, how do you provide an identity plane that flows throughout, your entire system once we figure out who the user is and tell everybody about it. And in my opinion, that's extremely useful input once you want to figure out what a person or a user can do, which is where you guys come in.
Right. Yeah, you say token, I say policy, right? We're all about defining an abstract policy that will describe in terms of parameters or attributes what can or cannot happen within the API landscape or the enterprise ecosystem. And we very much rely on the information that you can provide us because we don't do any of the authentication or identity establishment, if you will. We need to consume that information from you to then produce a decision as to whether access to whatever particular resource the client is trying to get access to should be granted or denied.
Exactly. And I think, a lot of these systems, as they grow and as they become complex, end up with the term spaghetti of trust, like where who said what to who and should I believe that or not? And our point, that Curity's point, is to exist as the single point of trust for that, so that there is a clean sort of structure in your identity plane of where identity information comes from and who said it's true and so on. So, and that feeds as one of the components into what is necessary to make that decision of should you not access. Because at the end of the day, nobody cares about who you are. If you think about it, everybody wants to know what you can do. Like, can I just want to access something. I don't want to authenticate. I don't want to do any of that. But you have to. You can't get around that. So our goal is to reduce that friction as much as possible and make it seamless as much as possible to that point.
Yeah, the analogy I have for that, Jacob, is when you go through passport control, when you travel overseas, they look at your passport. They're in a way authenticating you, but they don't particularly care that you're Jacob or Bob or whoever. They just care that you have the right credentials, the right passport, the right attributes to enter whatever place you're entering, right? So if you enter the European Union, you have to have an EU passport or you have to have a visa or something else, right? But who you are, unless you did something really bad and you're on that particular no-fly list, they don't particularly care who you are. Yep.
That's a good point. Don't want to be on that list.
You do not want to be on that list. No.
No. Yeah. So that's I think that's a good framing though of what to do, and we always talk about the whole like identity, or I should say API security nirvana. It's like when you reach the summit of a pretty steep mountain climb, and there's a lot of things you need to do in order to get to that summit. And one of the first things you need to do is, get your ducks in line, and know what do you have in your system. And as you do, then you need to start thinking, oh, where's identity? Can we pull that out? Can we centralize that? Can we make sure we have the trust in the right place? And as you figure that out, then you can start thinking, okay, now what about authorization? Can we centralize that? How do we pull that out? Where do we put these things? And so they kind of go, hand in hand a lot, these things, because if you do one right, it's much easier to do the other right as well.
It kind of flows naturally from that first layer.
Yeah, I'd like to think so, at least.
Yeah,
but I'm of course biased on the identity side of things, the token side of things. I don't see a conflict here, though, in contrast to how some discussions go here and there. I think it's natural to bind these two systems together, and it's needed if you're an advanced deployment.
Absolutely.
Now, I know you've talked about neo-security architecture. Could you explain to me and our listeners what that is?
So back before Curity, when we were solving these or building these platforms for companies, we were using off-the-shelf components to do that. Axiomatics was one, actually, to solve the authorization piece. But before we were sort of picking components, we kind of broke down the architecture of what's needed in order to perform. Nowadays, you call it SIAM, essentially. SIAM and API security, consumer identity and access management together with API security, those two pieces. And it turns out you need a number of distinct components, and they're architecturally separate. And they're separated by concern. So the old Unix paradigm, like you have each thing do what it's supposed to do, and you don't mix it, at least architecturally. So you have a federation service, you have an authentication service, you have token service, and user management service, and authorization has its own number of components as well in there. The standard named them nicely with the PDP, the BAB, and all of these things. So the neo-security architecture is really a blueprint for what that architecture looked like. And I mean, we've proven that in practice by all the companies we implemented that on before we started Curity. There was almost every project started with like, what should the architecture be? And we started sketching it out. And it's like, oh, it's the same again. And we wrote the big document with some changes on like, what they need and what's in there. But it's pretty much the same document all the time. So that led us to kind of define this architecture more strictly and say, we call it something. We call it the neo-security architecture. Then we said that's the components are one thing, but how they interact is another thing, which is the neo-security stack. And that is a suite of protocols and standards that you should be using in this. And there's authorization, SACML. There's OAuth, obviously, for API security. There's OpenID Connect for authentication to apps and sites and so on. And there's even SAML in there because sometimes that's what you need. So it's really like these are a number of protocols that are helpful. Here's where they fit, and here's the interactions between them. That's the neo-security architecture and stack put together.
So you said two things that really resonated with me. And before I get into those two things, breaking news, SAML is not dead. Now that I've got that out of the way. So you mentioned that neo-security architecture is, number one, modular, right? The idea that each component is focused on one specialist task and that you can combine the different components a little bit like Lego. I know as Swedes, we're not supposed to reference Danish technology, but for once, do that. But then the other one is, you kind of beat me to the punch, is standards, right? So you mentioned ZACML, OpenID Connect, OAuth, SAML, Alpha as well, Auth-Zen in the future. Can you tell me a little bit more how you use those standards, how you get involved with those standards, and whether our viewers themselves can get involved with those standards?
I mean, standards matters, first of all, because there's kind of two aspects of standards. One is interoperability. Like I can buy something off the shelf, which is what you want if you think about an architecture. It's nice that you can buy something off the shelf then. Security is, and these type of systems that implement these standards, it's fairly complex. And even if it's not complex on the surface, security is all about the details. Like you need to understand the details of the spec in order to be secure. Because if you don't, you didn't make it secure. The standards, they're very good at describing that, but there's also this sort of, you have to have a fairly deep experience and understanding in order to get that, what that is. So for that reason, people shouldn't, for the most part, implement these things on their own. And therefore, standards are even more helpful because they also then provide this interoperability piece where you can buy one and use it. And then there's, of course, a lot of nuances and some are better than others on various things and so on. But at the end of the day, that's two pretty key functions of what standards do. And being security, they're vetted because the people who write these are savvy. And they've been around for a long time, and they're not singular. There's not one person writing these. It's many, and they argue a lot. If you follow the mailing lists, which are open on IETF, you can see sometimes it's pretty heated arguments in there, which is good. I mean, that's the point, right? Absolutely. So yeah, I firmly believe standards are key here. It's tempting sometimes to be like, well, we'll just do this. But you could miss, very fundamental things very easily when you go out on your own and start thinking we can just solve this. I don't know. Early with OAuth, I don't know how many discussions I had with companies where like, we don't need OAuth. We're just using JSON Web Tokens, JOTs. That's enough. And to me, that's saying like, yeah, we have a car, we're safe. But, it's not the car that makes you safe. It's the traffic rules and the roads to combined with that and all of the pieces all together. That makes you safe when you drive the car, not just the car. And the protocols are that. They're all the traffic rules and the roads and everything around that. So yeah, but it's better now, I think. I think there's more understanding for that this is necessary, in my opinion, at least.
Right. So, you mentioned OAuth, as you alluded to the fact that it's an IETF standard. Then something you said that's really interesting is that the standard in itself is not enough. You also need the best current practices, or the BCPs as they're called within IETF land, which kind of guide you through the use of the standard. It kind of reminds me of I forgot his name. Bruce Schneier, who wrote the famous applied cryptography book back in, I think it was in the 90s or maybe even earlier than that. And he later said he regretted writing the book because they thought that by reading the book and applying the crypto algorithms, they were safe. When in fact, there's the management around it, the BCPs, if you will, of how to use a standard, a crypto standard in that case, or OAuth in our land and identity land to make sure that, it is secure. Because if you store tokens in an unsafe way, say on the client side, you're going to have issues. So OAuth, I would say, from my point of view, Jacob, is the access delegation standard, the basis for authentication. And then we have within the OpenID Foundation, OpenID Connect, which is the Authentication Federation standard, very similar to SAML in the past, which is an OASIS standard. And then jumping ahead, you have all of the authorization standards, so XACML or XACML, which is what Axiomatics dabbles in. And then Alpha, the abbreviated language for authorization, which is a spin-off of XACML, if you will, a more developer-friendly one. And then selfishly, sorry, that's my plug, OpenID Auth, which is about interoperability. What you said earlier is really important, right? We want interoperability where it matters. And in the case of authorization, it's great to have standard authorization languages for the policies, for sure. But it's even more important to have that interoperability between components, going back to the neo-security architecture. And you alluded to PEP and PDP. So having a standard PEP PDP dialogue over OpenID Auth, that's going to help get authorization up to the stage of OAuth and the identity and authentication side.
Yeah, I agree. I think that it's a very interesting project that's going on now with Auth. I think it's aiming appropriately, like you say. It's not trying to encapsulate everything you do with authorization. It focuses on the interoperability points, which is probably perhaps lessons learned a little bit, but also very prudent way to start something. I mean, OAuth did that cleverly as well early on. It completely ignored authentication, user authentication. It's clearly, stated this is outside the scope of the spec. Whatever happens between these two redirects, that's something else. And that was key, I think, for making that standard work really well.
Right.
Then of course there's a lot of, when you look back, it's like, it would be nice if they had done this or that and so on. But that's how it is. I mean, you can't win them all.
Right.
So auth-sen, I think, I mean, there's always that we take something XML based and then we JSONify it, but for some weird reason that could provide success. That's what OpenID had. I mean, they JSONified SAML more or less.
It makes it easier for the developers, and if developers adopt the technology, then you have a greater rate of success, right?
Yeah, I mean, it's surprising how many of the concepts in OpenID, almost everything, already exists in SAML. Like, it's not a whole lot of new inventions. It's a few, but it is doing it slightly different, making it a lot simpler to use, and that simplification is gold. It matters.
It's a great tribute, actually, to the work that was put into SAML 24 years ago now. It's a pretty old and sturdy standard. Speaking of standards, I want to switch a little bit to API security, and in particular OWASP, which is not a standards body, but sort of is a best practices body, if we could call it that. What can you tell us about OWASP, and how do you at Curity interact with API security and OWASP, and what are the things that you tell your customers they should worry about?
Yeah, I mean, OWASP, they produce a few things that are super interesting. They do a lot of good work, but they produce these top 10 threats for various things. I mean, they focus on web security mainly, of course, but they also have like a top 10 API vulnerability or list, which you should always read. It updates almost every year, I think, where they list like what are the most common mistakes you do, and they see out there in empirical numbers, and just by looking at that, it kind of gives you an wait, did we even think about that? So that's one thing. And then the other thing is, obviously, they provide testing tools, which are super helpful, and they provide a lot of recommendations for anything related to how you deal with credentials or users and that type of thing. But they don't really necessarily interpret the spec for you, and they shouldn't. And so there's this distinction. They kind of look at it from an attacker's perspective, Like, if I was the attacker, could I do this? Which is a super helpful angle, but that's not the same as going and reading it, and saying I should implement the spec like this. It's a long discussion maybe that we shouldn't get into, but they have that sort of attacker view, which is super helpful. And this top 10 list, it struck me as I was thinking about this podcast that I ran into a vulnerability, or I did. It was all over the news. Vulnerability in a few years ago here in Sweden, where a mobile payment service, was susceptible to the number one vulnerability on the API top 10 list, which is BOLA, broken object level authorization. And for those of you who don't know what that is, it's essentially when, say that you have a URI saying, item/ABC shows you the value of ABC. And if you change that to CDE, it shows you the value of CDE. Typically, in an OAuth protected system, if you will, you would want at least a correlation between what the token says you're allowed to see and what you can see. And, with a SACML-based backend, it should be even stronger on what you can see. So you shouldn't be able to access the wrong object. So what happened with this attack was that since it was based on phone numbers, the phone numbers were part of the URI. So turns out if you reversed engineer their application and proxied their security protocols, because it was fairly secure still, but if you proxied that in a fairly advanced way, you could change the phone number when you wanted to list transactions that were done, because it didn't actually check that it was your phone number when you listed the transaction. So you could see any person's transactions using this payment system if you broke it like that, and you could go in and just traverse, take a list of phone numbers and dump all transactions. And that is a sort of prime example of BOLA, I would say, from a banking company. It's not just whoever who wrote that. They're smart people and they know security. So tricky.
Yeah, and that's typically something that should have been checked in the application, or should have been checked in a dedicated authorization layer, like you said, with a policy where you check the relationship between the data and the incoming identity. You could actually have said, "Oh, hang a minute, you're not the owner of this transaction. Access denied." Absolutely. And to me, BOLA and IDOR, which are like very, very similar to the point of being the same thing, right? So IDOR is indirect object reference, if I remember correctly. They're so basic in their nature that it blows my mind that they still happen. But I think, the fact that you say that the people who built this particular case, they're really smart people. So it's just very easy to forget one part of your app stack. It's not that it was an easy attack to perform, right? It did require some digging. So it's just easy to forget some angle of what it is you want to protect.
Yeah, and I think, not to dive too deep here, but I think one key aspect to remember from this particular attack is that the phone number in this case is actually your identity. It's not just an attribute of you as a user. It's the actual identity in this type of payment system, because it's based on phone numbers. So it's even weirder to see it in a URL. Like, you pass the identity of the user account that you're actually accessing stuff for in the URL, which is, in my opinion, a big no-no. I mean, that should come in the token, and then that should be treated, because then you could just have said, list/transactions or whatever, and the identity is not there. It's just that's passed in the token, and this attack wouldn't even be possible.
Right.
So in that sense, it's a very simple. Yeah, it's a naive implementation almost, but I don't want to put that on them, because I know they're not naive, but it's easy to make mistakes like that.
And coming up on March 26th, we'll be joint hosting an event in London, and both of you will be speaking at it. Do you guys want to tell me what you're going to be speaking at the event and what people can expect?
Sure, I can start, Jacob, and I'll let you complete. But we're going to be talking essentially about the principles of the neo-security architecture, the principles of modular architectures, decoupling the different functions that you need for a secure API strategy. So the authentication layer, the federation layer, the access delegation, the authorization layers, right? Having all of these separate. And then, Jacob, you have more experience than I do in financial grade APIs. You wanted to add that layer, especially since we're in London. Do you want to add a couple words on what that means?
Yeah, so in the OpenID community, there has been a working group to talk about financial grade APIs, which is a dumb word because it doesn't have anything to do with financial anymore. So they actually renamed it to just FAPI and don't say what it means. But financial grade it's a nice word in one sense, because it kind of gets you to understand that it's more secure. Because financial systems need to be more secure. So financial grade APIs is about which part of the standards, because there's 105 of them now just covering OAuth and OpenID. Which of these specifications do you need in order to reach a higher level of security? And given the world, what it looks like, today, with all the frauds being, industrialized almost, you need more. With AI attacks coming up, I mean, the bar has been lowered for how easy it is to produce attacks and phishing campaigns and all these things. So financial grade is for everyone these days, and that's why I wanted to talk about it. How do you raise your bar and make sure you're covered on all bases?
I think shout out to the audience here. Come join us. The event I believe, Emme, correct me if I'm wrong, is like you said, March 26th in Shoreditch at the brewery. It's an afternoon event followed by a happy hour.
And they can sign up for the event on both of our websites. The links for signing up will be in the podcast description. If you want to join us, we'll be happy to see everyone there.
Curity.com, spelled Curity.com.
Curity.io.
Ooh, sorry. Curity.io. My bad.
Curity.io.
Curity.io. My bad.
Yeah.
Thanks both for joining, and we'll see our listeners on the next episode of the podcast.
Thanks, Emme.
Thank you, Emme. Thanks, David.
We hope you enjoyed this episode of Dynamically Speaking. Stay tuned for our next one, and in the meantime, check the show notes and connect with us on LinkedIn and YouTube. And visit us at axiomatics.com to learn more about our authorization solution.